So now we're going to talk about is heat treating. So there is different methods of heat treating or causing materials to change their composition without changing their chemical composition. So in steel, there are three different forms of iron. We refer to them as allotropes. There's the alpha, the gamma, and the delta. The alpha iron forms below 912 degrees Celsius, the gamma above 912 Celsius. Now there are other types of steel, but they're considered ceramics, so such as cementite, which is a ceramic, very, very brittle material. Now, face-centered cubic stands, or the FCC stands for face-centered cubic. BCC stands for body-centered cubic, and FCC is more tightly packed than compared to the BCC, but has larger individual gaps. Carbon fits into FCC better than it does BCC. So, heat treatment is a series of operations involving heating, then cooling the material back into its solid state. The purpose is to change the mechanical properties and the combination of mechanical properties so that the metal will be more useful, serviceable, and safe for definite purposes. By heat treating, a metal can be made harder, stronger, or more resistant to impact. Heat treatments can also make metals softer and more ductile. So no one heat treating operation can produce all of the characteristics. In fact, some properties are often improved at the expense of others. And if you're hardening, for example, the material will become more brittle. So the type of heat treating is annealing, normalizing, quenching, or also known as hardening, tempering, surface hardening, and case hardening. Annealing is the process of softening the material or bringing out the required change of the properties, such as the mechanicability or mechanical or electrical properties or dimensional stability. Annealing processes consist of heating the steel to its near or critical temperature, which is basically when the crystalline structure starts to change, and then you let it slowly cool down. If you let it cool down, the crystalline structure has time to reform into its original structure. So when annealing part is allowed and cooled in a furnace, it's called a full anneal or heat treatment. Now, normalizing is is a type of heat treatment that is applicable to ferrous material, iron-based materials only. It differs from annealing in that the metal is heated to a higher temperature, then removed from the furnace and air cooled. The purpose of normalizing is to remove the internal stresses induced by heat treating, welding, casting, forging, or forming, or machining. Normalizing is used in some plate mills in the production of large forgings such as railroad wheels or axles and some bar productions, and is less expensive than annealing. Now, quenching is done when you it increases the strength and wear on the property. One of the prerequisites for hardening is it has to have sufficient carbon and an alloy content. To harden it by quenching, a metal, usually steel or cast iron, must be heated into its austenitic crystalline phase, then quickly cooled down. Depending on the alloy, you can cool it down in like water or oil. But you can be done in forced air or other gases like nitrogen. There are other materials such as like salt water or polymers, but usually you see that in oils or waters. One drawback of this method by itself is that the metal becomes brittle upon hard quenching. This treatment is therefore typically followed by a tempering process, which then allows some of the stresses to be relieved. So you can look here and you can see where you have to heat it up and how much time you have to heat that up to get it into these different types of areas. So you have your austenites, your pearlites, and your bentonites. And those are all different types of steels with just different amounts of heat for how long they need to be in. Now, tempering is carried out by a preheating previously after it's quenched or normalizing steel to a temperature below the critical range and holding it there and then cooling it to obtain a desired mechanical property. Tempering is usually done to reduce the brittleness after quenching. Temperatures are usually chosen for the tempering process to directly impact the hardness of the workpiece. The higher the temperature in the tempering process, the lower the hardness. So you can look at here and see here is temperatures, and we can look at it. So first they're going to anneal it, then they're going to preheating it, and then they're getting it up to their temperatures. Then they're going to work it here, and then they're going to quench it, and then they're going to this is going to be the cooling and air, where they're doing their tempering cycles right here. They have 3 tempering cycles, and they're just kind of slowly bringing it well below that temperature. Now, surface hardening is when a treatment of steel by heating it heat or mechanical means to increase the hardness of the outside surface while the core still is relatively soft. The surface hardening steel is also valued for its low and superior flexibility in manufacturing. The oldest surface hardening method is it's called carburizing, in which steel is placed at a high temperature for several hours in the absence of an environment. The carbon diffuses into the surface of the steel and renders it harder. Another method of surface hardening is called nitrating, where you put nitrogen and heat, and camshafts for fuel injector pumps are also the same way. Valve stems are typically hardened by this process as well. Flame hardening and induction hardening, in which high heat is applied for a very short time by gas flame or high frequency electric current, and then the steel is immediately quenched, usually generates this also effect as well. Mechanical means of hardening the surface of the steel includes peening, where you hit it with a hammer, which the hammering of a heated surface as the iron pellets shot into the surface, or by air blasting, or cold working, which consists of rolling, hammering, or drawing out temperatures that do not affect their composition of the steel. Now, case hardening is the process of hardening the surface of the material, often at low carbon steel, by infusing elements into the material surface and forming a thin layer of harder alloy. Case hardening improves the wear resistance of machine parts without affecting the toughness interior part. You can if you have any questions, we'll be actually doing this in class the next time, and we'll talk about, and you guys will actually do your own quenching and hardening and tempering. So if you have any questions, please go ahead and ask.